Okay, so just a little intro to systemic and pulmonary circulation vessels, and then we'll get into the specifics. So, you know this, but pulmonary circulation or the pulmonary circuit is going to go from the right ventricle out through the capillary beds of the lungs and then back to the left atrium, right? Whereas systemic circulation is going to go, of course, from the left ventricle to all systemic capillary beds, way more of them, and then ultimately back to the right atrium. Okay, so let's look at pulmonary circulation, just an overview of it. Pulmonary circulation is much, much lower pressure than systemic circulation. So, why is that? What accounts for the difference in pressure that is generated in the two circuits? Anything you know about the chambers of the heart that accounts for that? So, since pulmonary circulation comes from the right ventricle, and the right ventricle musculature of the wall is so much less pressure goes into pulmonary circulation just because of the difference in the amount of musculature. So the pressure, comparatively speaking, in systemic circulation, average resting blood pressure in a systemic artery would be around 120 over 80, and 120 is the pressure, 120 millimeters of mercury is the pressure in the artery after ventricular contraction. It's like the highest pressure it's going to get to right then. And then the 80 is called the diastolic pressure. It's the pressure right before the next ventricular contraction, which would be the lowest pressure it gets to. So the variability in an artery would go 120, 80, 120, 80. Whereas if I looked at one of these arteries, one of these, where are we? One of these arteries right here that's going to the lungs, the pressure in like a pulmonary artery would be around 25 over 10. So meaning the pressure right after the ventricles contract coming from the right ventricle would be around 25 millimeters of mercury. And then right before the next contraction would be about 10. So the left ventricle generates way more pressure, and it also needs a lot more energy and nutrients than the right ventricle. So the general path, again, for pulmonary circulation is from the right ventricle to the lungs and then back to the left atrium. Okay, so let's just go through a couple things that you already know. So when the right ventricle pumps it out, it's going to pump it out the right ventricle to the pulmonary semilunar valve into the pulmonary trunk. And then the pulmonary trunk is going to split into the left and right pulmonary arteries. Good. Now, not shown on this picture, but just so you know, the right and left pulmonary arteries will actually split into what we call lobar arteries. And there are 3 right lobar arteries because there are 3 lobes on the right lung. And there are 2 left lobar arteries because there are 2 lobes on the left lung. Then, of course, it's going to go to the capillary beds of the lungs. And the capillary beds of the lungs are weird-looking capillary beds because it's a capillary bed that wraps around a little bubble called an alveolus. So what we would see is if we followed one of these, let's follow one branch of a pulmonary artery into the lobars, and then kept following it. Remember, we're still dealing with deoxygenated blood. We are going to deliver blood down to these little alveolar capillary beds. These pulmonary capillary beds are going to snuggle around an alveolus. And an alveolus is a thin little layer of simple squamous epithelium that air goes into when you have inhaled. And then because the alveolus is thin and the capillary is thin, oxygen can very easily move from the alveolus into the bloodstream, and carbon dioxide can very easily move from the bloodstream into the alveolus. And gas exchange is going to occur there. And you have a tremendous amount of surface area in healthy lungs for gas exchange, about the size of a tennis court in healthy lungs. So what happens is as you go by, this capillary bed goes by an alveolus, picks up oxygen, and then ultimately we are going to deliver it back to the heart. So the venules unite, they form small veins, and then ultimately you're going to form the 4 pulmonary veins that dump back into the left atrium. And then it's going to go left atrium, you know what it's going to do. through the bicuspid or mitral valve into the left ventricle. And then when I get into the left ventricle and I'm going to pump it out, I'm going to be in systemic circulation. Okay, so let's just do an intro to systemic circulation. How do we think about systemic circulation? Well, first off, there are way, way more vessels in systemic circulation because I'm not just going from the heart to its neighbor and then back to the heart. I'm going all the way up to my brain, all the way down to my little toes. So how do we think about systemic circulation? Let's think about arteries first. What do systemic arteries do? Arteries supply blood to capillary beds, whether they're systemic or pulmonary. But with the systemic, it's going to behoove you to think about which direction blood is going through that capillary, through that artery, and where it's going to end up, and also why. Remember, these arteries are delivering oxygenated blood to capillaries that need oxygen for cellular respiration. The tissues need oxygen for cellular respiration. So arteries supply. So when you are going through this artery, don't just point to it, figure out which direction blood is going through it. Systemic arteries, as I mentioned, are relatively high pressure. The pressure drops as they move away from the heart, not surprisingly. The left ventricle, because of the amount of muscle that it has in it, ends up working about 5 times as hard as the right ventricle because of the amount of nutrients and oxygen that it uses. And systemic arteries all are going to get blood from which ventricle? It's coming from the left ventricle for all of them. And you are going to pump it, of course, through the aortic semilunar valve into the aorta. And then, of course, there are 3 regions to the aorta. So we'll look at them here, and then we'll be looking at them as we go through systemic circulation. There is the ascending aorta, right, when blood is going up through here. There's the aortic arch when it's arching over, and there's the descending aorta. It's descending thoracic before it goes through the diaphragm, and then it's descending abdominal as it goes below the diaphragm. So those are both parts of the descending aorta. So you're going to follow everything from the aorta until it gets where it's going at a capillary bed. And then after it goes through the capillary bed, it's going to do gas exchange. And then you are going to pick that blood back up in what we call systemic veins. So let's just do a big picture understanding of systemic veins. So with systemic veins, again, there are a lot more veins than there are arteries. And there's also a lot more variation in veins between people, because you can have a variation in a vein and it can slow blood flow down. If it does, it doesn't matter that much because the blood is kind of on its way home, right? It already did its job, and it can fart around a little bit on its way back to the house. So lots more variation in both patterns and in location and in branching, all of that kind of stuff. And there's 3 times as many veins as there are arteries. You don't have to learn 3 times as many, but they do exist. And a lot of them are superficial. There tend to be a decent amount of superficial veins. If you look at your own wrists right now, or at the dorsal surface of your hand, you can see those superficial veins. Very few superficial arteries. Didn't really evolve that way very often. It's not very safe. Now, generally, a vein will run along with an artery and will have the same name as the artery, with the exception of the superficial veins, because those you're not usually running with an artery. And then what do systemic veins do? If systemic arteries supply a capillary bed, then systemic veins drain a capillary bed. So if I was trying to get blood back from the little finger, I would be draining it all the way back up. And then ultimately, where are these going to dump? They are going to dump, all of these systemic veins are going to dump back into the right atrium via either the superior vena cava, which is kind of, to oversimplify, draining arms and head, the inferior vena cava, which is, to oversimplify, draining everything below the heart, and then the coronary sinus, which was draining blood from the capillaries of the heart itself. So that's the big picture understanding. And then the next thing we're going to do is we're going to go through what I call systemic regional blood flow, in which I take blood from the heart and I deliver it like to the brain and then back to the arms and then back. So we'll do that systemic regional blood flow in just a minute.